Hello, welcome to my laboratory. I have no idea why you're watching this, but if you're still listening, let me tell you briefly what's going on here. Let's start off with some introduction. So, I'm Professor Cactusstein, and I'm a cactus, obviously. I was born this way. I'm not stuck in the ground, which may scare you, but that's okay. It's a rare form of a plant disease. You're probably wondering what this video is all about. Well, you won't believe what I've done. I clone myself. That's right, I've created a cactus robot. Here it is. Say something. Well, I still haven't programmed him to photosynthesize, so he's not able to function properly. I guess I'll just do some research on that. Let's see, Google Chrome. How to photosynthesize? Yeah. Oh, let's have a little laugh. I don't get it. Ooh, Wikipedia. I'd better get out of here. Why not a forum? Okay. Ooh. Ooh, that escalated quickly. Oh, a normal plant. A link for Bioch 10? That may help. Or not. As I told you earlier, I don't have rules, and so does the robot. We're ruthless. That is a problem because we can absorb the needed mineral nutrients from the soil, which are important for all plants. So my daily dose of minerals comes from Mineralin pills. Those pills are made specifically for plants with such problems. However, I cannot make the robot take pills, so I just mix all the minerals that are found in the soil and make liquid out of them. Something like fuel, you know? Here is a reservoir that has already some water in it, so I just add the minerals. Water shouldn't be neglected because, after all, there's no photosynthesis without water. I'm just going to put the container here, and we may continue. What else do we need? Oh, carbon dioxide. Luckily, I have a mask. I bought it on eBay last month. It's supposed to provide carbon dioxide. Let's hope it works. I'm still missing something though. Eureka! Chloroplast in light! Oh, I've put chloroplast already. I wanted him to be as green as possible. Apparently it didn't turn out as planned, but at least I won't need to implant more chloroplast in his robotic body. For the light, I just put a lamp. The light hits the plant. That excites an electron in photosystem 2 and powers its movement through an electron transport chain. Oh, by the way, photosystem 2 is number 2 because it was discovered after photosystem 1. Anyways, what the light also does is it splits the water in the plant into oxygen and hydrogen. The oxygen diffuses out of the cell and into the air where humans breathe it in, whereas the hydrogen stays in the lumen and becomes positively charged because it has lost its electrons which enter photosystem 2. While moving through the electron transport chain, the electron pumps protons from the stroma to the inside, so the lumen becomes positively charged. The positively charged hydrogen atoms then go through the ATP synthase, which uses phosphate and the hydrogen to make ADP. The electrons, which have already lost a lot of their energy, go to photosystem 1, where they're re-energized and later pass to an electron transport chain, where they're used to reduce NADP plus to NADPH. That's how light energy is converted into chemical energy. This process is also called the light-dependent reaction, and it occurs in the thylakoid. Next comes the light-independent reaction. NADPH and ADP formed during the light-dependent reaction are provided to the stroma and are used to fuel the Calvin cycle. The Calvin cycle is a series of reactions which reduce carbon dioxide to produce a carbohydrate known as glyceraldehyde triphosphate. The cycle consists of three steps. The first one is carbon fixation, during which CO2 is attached to ribulose 1.5-biphosphate, which results in a 6-carbon molecule that later splits into two 3-carbon molecules. This first step occurs with the help of an enzyme called rubisco. Step 2 is a series of reactions which use electrons from NADPH and some ADP to reduce carbon dioxide. In the final step, RuBP is regenerated. For every 3 turns of the cycle, 5 molecules of glyceraldehyde triphosphate are used to form again and again RuBP, or the ribulose 1.5-biphosphate. The remaining glyceraldehyde triphosphate is used to make glucose, glycerol, or fatty acids. 2 molecules of glyceraldehyde triphosphate make 1 molecule of glucose phosphate. Therefore, the Calvin cycle has to occur 6 times to produce 1 molecule of glucose. Since we're cacti, or a kind of cacti, we need some darkness to finish the photosynthesis. And that's all you need to photosynthesize.